Minnesota stands as a multifaceted testament to the power of nature, history, and innovation. Its landscapes are shaped by a complex interweaving of time, geology, and human interaction. Known famously for its lakes, forests, and northern wilderness, the state's natural legacy runs much deeper than surface beauty. Beneath its shimmering waters and towering trees lie geological formations and ecological systems that date back billions of years, telling stories of earth-shattering tectonic shifts, long-extinct volcanic activity, and the enduring influence of glaciers. The natural richness of Minnesota offers more than visual splendor. It provides crucial insights into environmental sustainability, renewable resource development, and the resilience of native ecosystems. The story begins with Minnesota's most famous moniker, the Land of 10,000 Lakes. These bodies of water, formed by the retreat of glaciers over 10,000 years ago, are more than tourist attractions. They are part of an intricate ecological framework that supports freshwater biodiversity, moderates regional climate, and sustains complex food chains. The glacial legacy left behind fertile plains, wetlands, and lake basins that collectively form an essential component of both environmental research and public recreation. These landscapes have helped scientists understand how life responds to long-term climatic changes, providing models for examining similar trends today. These lakes are not passive reminders of a glacial past. They are dynamic systems teeming with life, hosting rare species, and forming the backdrop for ecological studies that help chart the future of natural resource management. While the lakes define Minnesota's identity, its dense forests and sprawling prairies add to its diverse topography. These ecosystems serve as carbon sinks, regulate water cycles, and offer critical habitats for species ranging from moose to bald eagles. Deep within these forests and across its rugged north woods lie hidden corners still unexplored. These unknown tracts of wilderness provide ideal environments for researchers interested in discovering previously unclassified species or studying the nuanced interactions among flora and fauna in near-pristine ecosystems. Such work becomes even more urgent as human development encroaches on untouched lands and climate instability accelerates biodiversity loss. Minnesota is also home to the famed Iron Range, including the Mesabi and Vermilion ranges. These geological features contain vast iron ore deposits that powered the steel industry, catalyzing industrial development across the United States. Yet their significance is not just historical. In early 2024, researchers discovered a large helium deposit in the region, one of the most promising in North America. Helium, crucial in medical imaging, space technology, and nuclear applications, has been in short supply globally. The high concentration of helium found in Minnesota, well above the commercial viability threshold, positions the state as a potential leader in helium extraction. This discovery underscores how Minnesota's ancient geology continues to serve modern needs, creating a bridge between natural history and high-tech innovation. Exploration is ongoing, with scientists assessing the environmental impact, economic feasibility, and potential for sustainable extraction. If successful, this find could alter the geopolitical landscape of helium supply, reducing dependence on volatile international sources and reinforcing the importance of domestic resource security. The Boundary Waters Canoe Area Wilderness represents another jewel in Minnesota's ecological crown. This vast expanse of interconnected lakes and forests provides an unmatched experience of solitude and pristine beauty. It also serves as a living laboratory for biologists, ecologists, and geologists. Recent findings, such as the identification of two previously unknown species of freshwater mussels, highlight the area's biodiversity. These organisms contribute significantly to natural water filtration, supporting ecosystem health and water quality. The presence of such undiscovered species emphasizes the need for continued conservation and responsible access to these fragile environments. The ancient rock formations in the region, among the oldest exposed on Earth, offer a window into the planet's early geological history. These rocks preserve evidence of ancient tectonic forces and volcanic activity, revealing a chapter of Earth's evolution rarely accessible elsewhere. The presence of both ecological complexity and geological antiquity in the Boundary Waters marks it as a site of extraordinary scientific and cultural importance. Complementing Minnesota's surface beauty is a lesser-known world beneath its terrain. The state harbors an intricate network of caves, such as Mystery Cave and Niagara Cave. These subterranean systems house unique mineral formations, stalactites, stalagmites, and underground pools that reveal the state's deep geological past. The caves are still largely unexplored, offering researchers opportunities to uncover new mineral compositions or even microbial life forms adapted to extreme conditions. These systems may also contain clues about the region's hydrology and the historical movement of underground water. Their exploration could provide critical data on aquifer health, groundwater movement, and the resilience of subterranean ecosystems to environmental changes. These hidden realms contribute to the broader understanding of Minnesota as a layered and multifaceted state where the unseen is just as vital as the visible. Minnesota's North Shore along Lake Superior tells a story written in basalt and lava. This region's geological makeup is shaped by the Mid-Continent Rift, a massive geological fault that nearly split North America over 1 billion years ago. The cooled lava flows have formed towering cliffs and colorful mineral-rich beaches, which today serve as both tourist attractions and scientific marvels. Geologists study these formations to decode the tectonic history of the continent, learning about ancient volcanic eruptions, the structure of early continents, and past atmospheric conditions. These insights not only inform our understanding of Earth's evolutionary narrative, but also help scientists model contemporary geophysical phenomena. By analyzing mineral compositions, scientists glean information about the temperature, pressure, and chemical conditions that existed during rock formation, offering clues about the planet's early environment and the emergence of life. Minnesota is equally rich in cultural heritage. The state is home to 11 federally recognized Native American tribes, including the Ojibwe and Dakota nations. Their deep-rooted connection to the land transcends physical presence, encompassing spiritual, historical, and ecological dimensions. Sacred sites, including burial mounds, petroglyphs, and ceremonial grounds, stand as monuments to these communities' enduring relationship with the natural world. This cultural landscape invites a multidisciplinary approach to exploration, where indigenous knowledge complements scientific inquiry. By involving tribal perspectives in research and conservation efforts, Minnesota creates a model for respectful and inclusive stewardship of natural resources. The integration of ancestral wisdom with modern science offers a more holistic understanding of ecosystems, helping protect sacred sites while advancing ecological studies. The driftless area in southeastern Minnesota adds yet another layer of uniqueness. Unlike most of the Midwest, this region was never covered by glaciers, resulting in an uncommonly rugged terrain marked by steep hills, deep valleys, and complex underground water systems. These conditions have preserved spring-fed ecosystems that are highly sensitive to environmental change. Researchers are investigating how water flows through the karst systems, networks of limestone that dissolve to form underground channels. These studies are essential for understanding groundwater quality, as the porous rock allows pollutants from agriculture to infiltrate aquifers quickly. Monitoring water age, flow paths, and contaminant levels enables scientists to design more effective strategies for water quality management. This work is particularly urgent as agricultural runoff, including nitrates and phosphorus, poses serious risks to drinking water supplies and aquatic habitats. Protecting these springs ensures the continued health of ecosystems and communities that rely on this vital water source. Stream dynamics across the state also receive close attention. Minnesota's rivers are not static. They evolve continuously due to geomorphic forces like sediment transport, water flow variation, and human intervention. The Department of Natural Resources, DNR, monitors these processes to assess stream health and guide restoration efforts. Sediment movement naturally sculpts river channels, but activities like dam construction and agricultural runoff disrupt this balance, leading to habitat degradation and altered flow regimes. Understanding how rivers respond to both natural and human influences helps scientists develop conservation strategies that promote biodiversity and ensure water availability. The research has implications beyond environmental protection. It informs flood control, land use planning, and climate adaptation measures. In agriculture, Minnesota is becoming a testing ground for sustainable practices. With its fertile glacial soils, the state plays a pivotal role in America's food production. However, intensive farming raises concerns about soil health and water pollution. Researchers are exploring practices like crop rotation, cover cropping, and reduced chemical use to mitigate these effects. By enhancing soil fertility and reducing erosion, these techniques maintain high yields while supporting ecosystem health. Crop rotation, especially with nitrogen-fixing plants like legumes, decreases dependency on synthetic fertilizers and curbs nutrient runoff that leads to algal blooms. Planting cover crops that attract pollinators and beneficial insects also reduces the need for pesticides, promoting biodiversity. These practices are proving that environmental responsibility and agricultural profitability are not mutually exclusive. Farmers are beginning to adopt these methods, supported by scientific research that demonstrates long-term gains in productivity and ecological balance. Climate-ready crops are also at the forefront of Minnesota's agricultural research. As the state grapples with increasing weather extremes, droughts, heat waves, and floods, scientists are developing new crop varieties with enhanced resilience. Traits such as deep root systems for drought resistance and heat tolerance are being bred into staple crops like wheat and corn. This effort involves both traditional breeding and advanced genomic techniques, leveraging global seed banks to introduce desirable characteristics. Climate-resilient crops not only safeguard food security, but also reduce the need for intensive irrigation and chemical treatments, thereby conserving resources. Additionally, resistance to new pests and diseases brought by climate change is crucial for maintaining yield stability. By ensuring crops can thrive under changing conditions, Minnesota contributes to a more robust and adaptable agricultural system. Minnesota is more than the sum of its natural features. It is a dynamic, living landscape where past, present, and future intersect. Its ecosystems are resilient yet vulnerable, ancient yet relevant. The integration of scientific research, indigenous wisdom, and cutting-edge technology positions the state at the forefront of environmental exploration and sustainability. From the Boundary Waters to the Iron Range, from subterranean caves to drifting prairies, Minnesota continues to inspire curiosity and innovation. Its landscapes, both visible and hidden, serve as classrooms, laboratories, and sanctuaries for all who seek to understand the Earth and their place within it. The promise of Minnesota lies not just in what it is, but in what it may still become. A place where discovery never ends and where nature's enduring legacy fuels humanity's most pressing quest for knowledge, resilience, and harmony with the planet.